All right, so this is the last section of chapter 3, and this is unit conversions. So you're going to be converting between moles, grams, and atoms. And all of these are just measurements of how much stuff there is. So first, just to remind you, we already talked about this on Mole Day, but Avogadro's number, which is represented by 6.02 times 10 to the 23rd power, lots of zeros. It looks like that if you wrote it out. You don't have to know written out. I won't ask you to write it out, but you do have to know the number. Avogadro's number just represents the number of carbon atoms or particles in 12.01 grams of carbon. And carbon's in basically everything. So they used carbon because it is such a common element to find. So 6.02 times 10 to the 23rd just represents a measurement. It's like saying you have a dozen donuts, you have 12 of them. Or you have 12 inches, which is a foot. So we call the mole how many particles are equivalent to Avogadro's number. So 6.02 times 10 to the 23rd is called the mole. Just like I said, we say 12 is a dozen. Same idea. So the mole just represents that specific number, Avogadro's number. And chemists like to abbreviate, so they abbreviate mole as MOL. I know it's only one less number, or one less letter, but it is an abbreviation. So once again, 6.02 times 10 to the 23rd is Avogadro's number, which is also called a mole. So just a quick video, you already watched this on Mole Day, but once again, the mole is a hard concept to understand because it's hard to picture 6.02 times 10 to the 23rd particles. So here's just a quick video to remind you of what a mole is.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your aunt's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you have equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amedeo Carlo Avogadro. Wonder how long it took him to sign autographs. Unfortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particles. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind, Avogadro was the first one to come up with this idea, scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number. Now, back to the mole. Not that mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or a 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. Okay, now we sort of have an idea how large the mole is. So how do we use it? You might be surprised to know that chemists use it the same way you use pounds to buy grapes, deli meat, or eggs. When you go to the grocery store, you don't go to the deli counter and ask for 43 slices of salami. You buy your salami by the pound. When you buy your eggs, you buy a dozen eggs. When we hear the word dozen, we probably think of the number 12. We also know that a pear is 2, a baker's dozen is 13, a gross is 144, and a ream of paper is... anybody? A ream is 500. Well, a mole is really the same thing. For a chemist, a mole conjures up the number 6.02 times 10 to the 23rd, not a fuzzy little animal. The only difference is that the other quantities are more familiar to us. So there you have it, the story of the mole, Avogadro, basketballs, and how to buy salami at the grocery store.
So as I said before, a mole is just a very big number, and we say mole instead of saying that very big number every time. So talking about unit conversions, it's like going from quarters to dollars. 4 quarters equals $1. If you have $2, you have 8 quarters. If you have 8 quarters, you have $2. It's kind of the same idea. So our first unit conversion is moles to grams. So going from moles of a substance to grams of the same substance. In order to do that, you're going to multiply by the atomic mass of the element. And the atomic mass is found from your periodic table. Remember, I said before, you can either use that exact number from the periodic table in decimal format, or you can round it. I just warn you that if you're rounding it, you need to make sure you're rounding it appropriately and not over or under rounding, or that will mess up your answer. Okay, so for example, what is the mass? Mass is measured in grams of 3.5 moles of copper. Okay, so I start with 3.5 moles of copper. That's the number given to me. And I'm going to abbreviate mole, and copper is Cu. You can always abbreviate. Okay, and then we're going to have one set of parentheses. You have to show your work with this. 1 mole of copper is going to go on the bottom because we want this unit to cancel that unit. Now I'm going to look at my periodic table. Copper's atomic mass is 63.546. So you can use that exact number or you can round it. It's up to you. I'm going to use the exact number. And I'm going to grams, so G is going to be on the top of, once again, copper. If you wanted to round this to 64, that would be fine. So now in your calculator, you do 3.5 times the top number times 63.546, or whatever you round it to, and then you divide by 1. My answer is 222.411. I always say go to 2 decimals. So let's go 222.41 grams of copper. That is my final answer. So 3.5 moles of copper equals 222.41 grams of copper. Okay, so you put your number out front in moles, you multiply by the atomic mass using your periodic table, you divide by 1. Your final unit is grams of copper because I'm finding grams of copper. All right, what happens if you go the opposite way? What if you go from grams to moles? So now you're going to divide by the atomic mass. So how many moles of aluminum are in 11.9 grams? So start off the same way. I'm given a number, 11.9 grams G of aluminum Al. And now I'm going to divide by the atomic mass. So it's going to go on the bottom. So looking at my periodic table, aluminum's mass is 26.982. So aluminum's mass is 26.982 grams. You can either use that or you can round it to 27. Doesn't matter to me. I'm going to round it. Okay, so 27 grams of Al. That's going to cancel. That's good. And I'm finding how many moles. So 1 mole on top. Whatever you're finding is going to be 1. So now I take 11.9 times 1 times the top divided by 27. And I get 0.4407 blah, blah, blah. I'm just going to round it 2 decimals. So this is 0.44 moles of aluminum. Final answer. Once again, I put my number out front. Whoops, I didn't mean to cross it out. I put my number out front, 1 mole on the top, divided by the atomic mass of aluminum from the periodic table. Grams to moles. All right, what happens if you go from moles to atoms? If you go from moles to atoms, you multiply by Avogadro's number, which I've given to you. So how many atoms of sulfur are in 0.125 moles? So I'm given the number out front, 0.125 moles of S sulfur. I don't need to look at my periodic table. I am multiplying by Avogadro's number. So multiply by 6.02 times 10 to the 23rd atoms. You can't abbreviate atoms of S, sulfur. And then 1 mole goes on the bottom because I want this unit to cancel out that unit. Okay, this one's a little trickier to put in your calculator. So I would put in 0.125 times, and then I'm going to put a parenthesis. So I click the parenthesis in my calculator and I type 6.02 times 10 to the 23rd, or you can do 6.02, the EE button, 23, whichever you want to do. The EE button is times 10. That's what it means. And then end parenthesis, and you don't have to divide it by 1 because it's going to be the same number. My calculator says 7.525, and then up here it has 22. Okay, so I'm going to round it to 2 decimals, 7.5, let's go 3, because this would round it up, and then times 10 to the 22nd power atoms of sulfur. If you're having issues putting that in your calculator, if you at least show me the correct work, you're going to get most credit. Okay, so I multiply by Avogadro's number, and in my calculator, I put this in parentheses, and you can either type it in like this with the little caret to the 23rd, or you can type it in like this. They mean the same thing. All right, last conversion is the opposite, going from atoms to moles. So you're just going to divide by Avogadro's number. So how many moles of tin are in 2,500 atoms? So 2,500 atoms of tin, which is SN. Now I'm dividing by Avogadro's number. This one's a lot to write, but that's okay. And then 1 mole goes on the top. So my atoms cancel out my atoms. I'm good to go. So in my calculator, I'm going to type 2,500 times 1 times the top divided by, and then I'm going to click a parenthesis, 6.02 times 10 to the caret 23rd, end parenthesis, or you can type it in as 6.02 EE 23, whichever. And my calculator reads this. Lots more numbers. Okay, so I'm going to put my final answer is 4.15 times 10 to the negative. Let me rewrite that. It's all sloppy. I'll write it up here. 5.1 or 4.15 times 10 to the negative 21 moles of tin. That's my final answer. Once again, if you're having issues typing into your calculator, if you at least show me the work, you're going to get most of the credit. So that is unit conversions, moles to grams, grams to moles to atoms, or atoms to moles. 4 options, no matter what numbers, always the same process. And that's the end of the chapter.